All right, so let's get started streaming. I have first got to check to make sure my mic is working. It usually is. All right. Yep, it's working fine. I am streaming on Twitch tonight, and I'm also streaming on YouTube with a live. I've kind of switched to YouTube for my lives. I'm trying to go down that road. Twitch is more of what I'm just leaving aside for gaming, but I am still streaming there. So I've got the ability with Restream to stream in both places. So this down tempo that I've got seems a little loud. I don't want to drown out the empirical rule, so I'll turn it down just a little bit. Let me double check. All right, that seems a little bit better. Okay, so what I'm going to cover tonight, last Wednesday night, I covered a lot of topics in that particular class. So we covered, and some of it we covered a little bit before with mean, talking about measures of center, talking about mean, median, and mode. I went back and revisited mode last week in one of my live videos, and I also revisited in class a little bit because I did a disservice, kind of dismissing it. So I brought it back around and showed where it could be useful. Talked about mean again in detail, talked about median in more detail, talked about measures of variance, talked about variance itself, the standard deviation and range, and then moved on to measures of positions. Now, what I left measures of position, what I left out was, in the variance section, I left out empirical rule. And what I left out in measures of position were z-scores. So what I want to do tonight, I may not get to z-scores, I may just do a quick video on empirical rule. I want to walk through empirical rule to some extent, talk about symmetrical bell-shaped curves just a little bit, and I will let you know right now that we are going to do a huge unit on the normal curve, so that by the time you walk out of here, you should be an expert on it. Empirical rule is just the beginning, so this is just the overlay before we get into the normal curve. Now, as always, at the beginning of my stream, I like to pretend to be a pro streamer by talking about what I'm using to stream with. I am using an iMac from 2015, which is old. It doesn't even take any updates anymore, but it still works like a champ. I have to give it credit. I am streaming tonight from Restream. There are two mediums that I use to stream with. Restream is one of them, and Ecamm is the other. I like Ecamm a lot, but I have to admit that Restream is very easy for me to stream my stats online office hours. This to me is easier to work with. Ecamm is very easy to work with too, by the way, but there's just some finagling and some consistencies to keep it the instructional design of it accurate throughout each slide or throughout each frame. So this is just easier to work with because it's more of a stream in a box kind of thing. And it's not about the stream as much, even though it's a big piece of it, but it's more about the material. So what I'm going to talk about tonight, now that I've laid out to you my pro streaming setup, as you see, I bring my phone up to check whether my mic's working or not. That's certainly professional. Let me do this. Use my Stream Deck to earn back that $150 I paid for it 5 years ago. All right, so let's talk about bell-shaped distributions. Bell-shaped distributions relate to symmetrical curves. And let me just give you kind of an overview with one of my sketches, and then I'll take you to a little bit better drawn picture. All right, that's one of my sketches. That's actually not too bad. This is a distribution that is approximately symmetrical. In other words, if you remember from class, if we split it right down the middle, and fold it over, then each side would fit, one side would fit on the other perfectly. So this is a approximately symmetrical bell-shaped graph. The mean and the median and the mode for a bell-shaped graph are all right there in the middle. Now, we're not going to mess with that tonight. When we get into normals, we'll talk about that a little bit more. But tonight, I just want to talk about the breakup of this and how the data falls. So we've talked about standard deviations, not with how they relate to a symmetrical curve, but just overall. Let me shift this over a little bit. There we go. I just want to make sure I don't miss any of the any text that might come in from anybody from class. Of course, you didn't know I was streaming tonight. This will be more like a video on demand for you, just to get a little bit extra before we go into class Wednesday. So as you look at this, you've got the center of the circle right here. So when we're talking about z-scores, which again we haven't covered in detail, when I go out one standard deviation away in each direction, then that has a certain number that relates to it in terms of how much data falls there. So in this symmetrical curve, how much data falls between one standard deviation on one side of the mean and one standard on the other. Now that 0, keep in mind, is a measure of position. That's the center. We go out one standard deviation one way, one the other. The negative sign doesn't mean that that particular number is negative. It just means that it is less than the mean. So the next thing we're going to do is go out. I'm never going to, my drawing is off. This is not to scale. So the next thing we're going to do is go out 2 standard deviations. And that would be, and the question would be, how much data falls between 2 and -2 standard deviations away. And then we're going to go 3. We really don't need to go any further. And again, please, anybody that's watching that knows normal curves, please understand this is a sketch. This is way off as far as the scale goes. Oops. But now we're looking to see how much data falls between 3 and -3 standard deviations away. So I'll go ahead and give you these 3 numbers right here, and then I'll draw a little bit better picture and try to draw it out better before I show you a text picture that is drawn much better. All right. So between 1 and -1, in other words, in this, whoops, let's go with light blue. In this middle right here, you're looking at 68% of your data falls there. So when you've got a symmetrical bell-shaped curve, 68% of the data falls between 1 standard deviation on either side. When you are saying between, this is going to get messy. Between 2 standard deviations, this looks terrible. I don't know what I was thinking. When you're looking at between -2 and 2, which in other words 2 standard deviations on either side of the mean, you're looking at 95% of the data. And when you go all the way out, when you're looking, I think I used green already, let's go with a little darker. When you're looking from -3 to 3, you're looking at almost all of it. So you're looking at 99.7% of the data falls between 3 standard deviations on one side and 3 on the other. So there's your 3 numbers. So these 3 numbers are very important with respect to the normal curve, but these are also very general numbers. You're going to find that as we narrow in on z-scores, in other words, not just from 1 to 1, but from 1.2 to -1.72, whatever, when we're going between those, you're going to see that the generalizations help you make sure that you're on the right track logically, but we'll have a whole lot more accurate numbers to go in there. Okay, very messy drawing, bad. Let's now go to, let's see if I can bring it home a little bit easier, but look at the text. Wow, look at that. Great. Okay. Hopefully you can see this okay. I'm going to look on my phone here and see how it shows up. A little bit of a delay. Okay, a much better drawn normal curve up there at the top. Let me pull out of this and let me go to here so I can see this a little bit better. I'm not so sure that I don't need a new iPad. Just talking out loud. Okay, and that doesn't help me see any better, so I'm going back to there. All right, so when you're looking at this picture right here, this is exactly the same thing I said, but this is broken up a little bit further. If you see the two blues, I wish I could narrow into that. You see the two blues in the middle at 34%. Well, if you add 34 and 34, that comes out to be the 68% that I was talking about a second ago. When you go from, and notice there that in the middle, X bar, that's your mean. I'm actually looking on my phone to see how big or small that is. Let me switch this up. Give me just 1 second. Let me replace this with let's replace it with Text Me at Snagit, which is where I pull my stuff from, although it didn't seem to replace now, did it? Alright. Screen share entire screen. There we go. Maybe now. No, why would it? Let me go back to my previous slide. There it is. Okay. Good enough. And I am going to change this just a smidgen. There we go. Okay, much better. So now, and now I can override. It's a little bit better than the book in this sense. Gosh. I tell you what I did with my iPad. So I have a regular junky, just a regular 10.5 inch iPad. My wife got it for me a few years back. Just a regular iPad. I did not like the way the pencil drew on the glass. The latency was off. It was hard to mess with. So I put a cover on there that makes it more paper-like, and it is fantastic. But sometimes I have a hard time pressing getting to go where I want it to. So there's my iPad discussion. Okay, now this is a little bit better, and I can override this. Now, if you look right here, this is what I was talking about. That 34 and that 34, that becomes your 68%. So in other words, all of this right here is 68%, which is what I just talked about, between 1 and -1. You got to get these three numbers out. They're on that note sheet that you're studying, so these are three numbers that you have to know, at least for assessments in the classroom. Again, once we get to normals, you won't need to know them because we're going to be getting exact numbers in there. So that's the 68%. So this here, let me go. There's X bar. And I can see that okay on my screen. It looks a little bit better on my phone there. There's X bar. So there's the middle of it. Now, we are going to go, I keep having to change colors so we're going to go from 1 standard deviation on one side of that mean to 1 standard deviation on the other. So we're going to go from here to here. And I'm going to rewrite it down here. 68%. Why is that not showing up? Showing up here. There it is. Okay. A little bit of lag on my connection to the phone. There's 68%. Okay. Now, when we go from, and that was here. Now, when we go from -2 to 2, we're looking at 95%. When we go from 3 to -3, we're looking at 99.7. So once again, I can't emphasize this enough. Know this, and that is between -1 to 1. Know this, that is from -2 to 2. And know this, that's from -3 to 3. Hopefully that comes out. Hopefully you understand that, at least in the context of this discussion. I was going to write stuff below, but as you notice, even my 68's cut off, and for me to go back and mess around with it would just be wasteful time, I think. So there's that. Okay? Okay, so let me talk a little bit about numbers in between all of that. So let's say that I want to find from, and you can see the numbers on here are laid out for you, and I'm not going to go with any abstract numbers in between. We'll do that when we get to the normal. But let's say that I want to go from -1 to 3. That's about 84%, isn't it? Oops. Because we're going from 3 all the way over here to 1 right there. So this is the mean, median, and mode. So from here to infinity is 50%. Even though we're stopping at 3, there's not much more on the other side of that curve. The normal curve approaches that horizontal but never reaches it. It's asymptotic. So it just keeps going and going, getting infinitely close to the horizontal but never touching it, which means there is area under there all the way to infinity, but it's just minimized. There's not much to it. So when you're out at 3, you're just about to the 100% mark, really, because you see that's 99.7. So if we just use that 50% plus that 34%, then we're sitting at 84%. Those are the kinds of calculations that I want you as students to be able to make. Now, for assessment in my class, if you understand it to that degree, I'm okay with that. If you understand it to even more of a degree and you say, well, to 3 to -1, it's going to be less than 84% because we're not going fully out, I get that too. But it's going to be right about that mark right there. And generally speaking, for the logic of it, that's what I want you to know. Okay. Nobody's come on. Nobody knew I was coming on tonight, so certainly none of the students might be on. And why wouldn't you want to be on June 2nd, 7:20 on Monday? Everybody would want to be on. So let's take a look at... Oh, me mo. Let me get off of this. I've lost my mouse. I have no idea where it's at. I got 3 screens. This stupid mouse. There it is. Okay. Let's go to my library. And let's go to here. Let's backtrack for a second and let's do a couple of problems. So now I'm looking at find the range, mean, variance, standard deviation of the population data sets. Okay, no problem. So I'm kind of impromptu, so if you see me looking around at what to do, it's because I don't have an exact 1, 2, 3. I've got a set of problems, but not an exact direction to go in. So let's talk about number 11. Let's start here. So let's start with number 11. So we've got find the range, mean, variance, and standard deviation of the population data set. I'm very generically going to work this out on the black part around this screen. So if I want to find the range, if you have a question like this on an assessment, just keep in mind that this is a gimme problem. Give me more of these because it's really easy. The range is just simply take the largest number, subtract the smallest number. So in the case of this set, 12 is the largest number, minus 5. And 12 minus 5 equals 7. Very easy numbers to work with. So the range would be 7 in that instance. If we were looking at this next one, this next problem right here, number 12, let's do the same thing here. And I am looking at the range of that one. Be the largest number, which is 21, 22, 25, looks like. So I have 25, subtract 15 equals 10. So the range of that second set, number 12, is 10. Again, not rocket science type questions, but I want you to be able to do this muscle memory like the back of your hand. You shouldn't have to think, man, what is range? It's just the largest number, subtract the smallest number. Now I'll double check that last one because I'd hate to be on the World Wide Web and make a mistake. So 25 is the largest number. And 15 is the smallest. No problem. Okay, I'm going to do away with range on here. So let me erase. Here we go. Now, with this problem 11, let's find the mean. As you can see, I'm not going to have enough room to show everything. So I'm going to use the ... method that I used in class. We just want to be able to set this up. So to find the mean of this set, Range, mean was next, yeah. And this is a population data set, so it's going to look like this. The mean is the summation of the x's over how many there are. It's going to be, and I'm just going to go left to right. I don't have to put them in order. Commutative property says I can add these in any order. It's going to come out to be the same thing, so I can just go left to right. So I've got 9 plus 5 plus 9 plus 10 plus ... plus, and I'll just go to the last number in the set. And if you remember from class, that ... just represents all the numbers between 10 and that last number 12 in the set. I've run out of room. And typically you'll have some type of technology there, or you will have worked it out yourself on paper. How many are there? There's 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of these. So that's it. I add up 9 plus 5 plus 9 plus 10 plus all the other numbers all the way out to 12 and divide by 10. That's going to give me my mean. Okay? Now, if I go to the next, it wants us to find the variance standard deviation of the population. Okay, so let's look at number 11. Number 11, in terms of now the variance. Okay, so this is a population variance, so it's going to be lowercase sigma square equals the summation of the x values, subtract the mean, squared, because remember, if you don't do that, you just get a sum of 0. All divided by big N. Okay, I'm going to start this. I'm not going to go through all the numbers because we are working with still number 11, but I won't have enough room on this page. So okay, I hope I got texts coming in. I hope they're not coming across in the stream. Not that there's anything wrong with them, but anyway. All right, so I'm looking at, and I'm just going to go left to right again. So I've got 9 subtract whatever the mean is. Let me find the mean. So I'm going to go 9 plus 5 plus 9 plus 21 plus 12 plus 7 plus 7 plus 8 plus 12 equals, divided by, how many did I say there were? 10. So it's just 9. So the mean equals 9. So I can now use that. Go back to that peach color. And I'm going to go 9 subtract 9 squared plus, next number is 5 subtract 9 squared plus ... plus the last number, which will be 12 subtract 9 squared. Again, I'm using the same method to set it up. I'm using the same method to set it up, and then I'm just going to divide by n. We are working with a population here. No problem. So I want to backtrack for a second, look at some of these. Then I've got a couple of problems with empirical rule, and then I'll probably call it a night unless anybody comes on and wants to chat. So there we go. So I found the mean up there, and then I found the variance down here. Real quick, does it want us to find the standard deviation? Yeah, it does. So it wants us to find the standard deviation as well. If I want to find the standard deviation, then all I need to do is take the square root of the variance. So whatever number I come up with for the variance, I just take the square root of it, and that is the standard deviation. I hit my desk, and it's a very professional setup, this is. So there you go. All right, so let's look at the ones down below. They're dealing with a sample data set. So let me just erase all this out. Hopefully this is okay for you. And this kind of stream where I come on and do this, if you come back and watch this and you have questions, as always, we are a face-to-face class. This is just online office hours that I do to supplement. I enjoy doing this. I like the interaction when people come on. In the case of this type video, this is just a video on demand because I didn't get through everything last Wednesday. Excuse excuse me, I left z-score and here we go. Okay. Now I can go back to this. My big head was covering up the previous. So now I'm going to go back to this. And now we are going to work with these problems. In 13 and 14, find the range, mean, variance, standard deviation of the sample data set. Why is that stuck there? Maybe it was there earlier. Okay. Probably because I froze the screen. Never mind. Okay, so we're working with 13, and we're going to find the range. I'm not going to find the range, and I'm not going to find the mean because that's the same for a sample. Let's look strictly at variance and standard deviation because those are the ones that are going to change slightly with a sample. So if I'm looking at number 13 and I want to find the variance, this is the variance of a sample. Because it's a sample, you're going to be looking at s squared equals summation of the x's, subtract the mean. It's the same in the respect of the numerator, except that you're using x bar to represent the mean as opposed to mu for the population mean. I'm going to divide by n minus 1. I'm going to take into account that sample is smaller than the population, and the population having many more items in it is going to have the ability to have more variance. So I'm going to take that into consideration with my sample, and I'm going to divide by n minus 1, thus making the denominator larger. Same way we work it out. I'm still going to look, and I'm just going to go left to right because I'm not doing the median where we have to put them in order or finding the 5-number summary where it helps to put them in order. I'm just finding the variance. So I got 4, I don't know the mean, daggone it, like 4 plus 15 plus 9, 12, 16, 8, plus 11 plus 19 plus 14 equals, divided by 3, 4, 5, 6, 7, 8, 9. Divided by 9, but it's 9 minus 1, which is 8. No, it's by 9. Because that's the mean. 108 divided by 9. I'm sorry. So the mean is 12. And it's not that mean. The mean is 12. Okay. So when I go back up to my layout, I've got 4 minus 12 squared plus 15 minus 12 squared. That's not a very good minus, is it? Plus dot 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 plus 4, 15, all the way out to 14. 14 subtract 12 squared, and that's it. And then divide by, in this case, 9 was how many were in the set, so we're going to divide by 8. Ta-da! There's the setup. I won't work through all the subtle pieces of that, although I did find the mean for each of these. Not very hard with a small set of just integers. Not hard at all. And then once I find the variance, once I crunch these numbers, then I just take the square root of that, and that gives me the S, which for the sample, the S represents the sample standard deviation. Ta-da! Just a couple of extra problems that I've thrown in because I had them up here in my Snagit portfolio. So now let me erase this out. I've frozen the screen. Do I have to unfreeze it? I think I do. Let's unfreeze that. Find my mouse that I keep losing across 3 stupid screens. Go to library and let's bring up this. And let's talk about at least one of these. I don't know if I'll do all 3 of them. I am running into about 33 minutes of rambling, talking about the empirical rule. Let me do at least one of these. And let me make it, do I need to make it, can I make it any bigger or smaller? Well, I don't even know what I'm doing. Okay, fine. Okay, so let's look at this first one. I'm looking at my phone. It's kind of small. You probably have to look like this. On my computer, I can see it pretty well. So the mean value of land and buildings per acre from a sample of farms is $1,500. The mean value of land per acre from a sample of farms is $1,500. So the mean. So the data set has a bell-shaped distribution. So we are given some information here in number 33. And we are given that the mean is 1,500 with a standard deviation of 200 right there. So I've got a standard deviation of 200. Okay? Estimate the percent of farms whose land and building values per acre are between 1,300 and 1,700. So the percent. We were working with percents with the empirical rule. Logic would tell you that if I have now moved to an empirical rule problem, I'm probably looking for some derivation of this in my answer. Now maybe not. Maybe it's some 13.5 plus 50 on either side like I did with the 84 a second ago. But I'm probably looking for one of these three. Okay? So let's take a look at this. I'm going to draw a very small normal curve here. Let's see how well I can do it. Let's go from it's actually okay for me. No problem. Okay. So in the middle is the mean. And that is 1,500. One standard deviation away is plus 200. So here, and I'm just going to write it above. There's no, oops. The reason I'm writing it above, sorry about that. My big head out of the way. The reason I'm writing it above is because I'm just out of room. So I've got 1,700 here. If I go out one standard deviation this way, I'm going 2 below. So 4, 3, I've got 1,300 there. Now they were asking us 1,300 to 1,700. I've done all the little calculations I need to do. I was given this information. I drew a sketch. I put my mean in the middle. And then I went out one standard deviation, which was plus 200 and subtract 200. And I'm between 1,300. Let's go different color. I'm between here and here. So what percentage is between one standard deviation on one side and one on the other? Well, that goes back to 68%. Ta-da! First one's pretty easy. I'm going to leave it at that, though. I think we will finish covering this in class. Hopefully this was a good overview for you for empirical rule, which I just did not. We had reached our time last Wednesday. We have a very long class, and when you cover as much material as I did last time, there's just some things I don't mind pushing off a little bit, and I didn't mind putting it in this video that I'll leave out here for video on demand. So for anybody that stops by and watches this, I appreciate it. If you ever stop by, if you're on YouTube, just leave me a chat and just say, hey, appreciate this, Mike. That was good, or that was bad. Work on it. Come in the chat if you have any questions or if you want to discuss it. I'm in a stats class, or I'm a stats teacher, or what have you. And we'll talk about online office hours, whatever you want to talk about. And I can always bring folks into the live if you want to interact face-to-face. You don't have to show your face or your full name or anything, but we can talk about it. But anyway, back to the original. I appreciate you stopping by, either on YouTube or on Twitch. I will be back on tomorrow night. I will cover empirical rule again, backtrack a little bit to measures of center, variance, and 5-number summaries for position. And then I'll talk about z-scores, which I didn't talk about last week. And I may, usually my Tuesday night is a prep for Wednesday. I would typically go into, say, probability, which is the next section we'll go into. So I'll debate whether I do all of that tomorrow, whether I go into probability, but it'll be one or the other. So anyway, thanks for stopping by. I do appreciate it. And I will see you hopefully tomorrow night. And if not tomorrow night, Thursday. So